Hello, welcome to Forest Learn. In this video, you can try a 1-mark question on simple harmonic motion. After you've had a go at the question, we'll discuss the solution so you can check your answer. In case you don't know, simple harmonic motion is commonly shortened to SHM, so I'll mostly just be saying SHM throughout this video instead of simple harmonic motion. Let's take a look at the question. A mass m is performing simple harmonic motion, SHM, with amplitude A, time period t, and angular frequency omega. What is the time period of the mass if its amplitude doubles in terms of t? Please pause the video and have a go at this now by yourself. When you're done, unpause the video and we'll discuss the solution. Okay, welcome back. To answer this question, we have to recall what the time period depends on. Hopefully you'll know or remember that the period is related to the angular frequency by the following. T, the period, is equal to 2 pi divided by omega, the angular frequency. Now, what does omega depend on? Well, that depends on which specific example of SHM we're considering. If we're considering a mass spring system, then omega is equal to the square root of k over m, where k is the spring constant and m is the mass attached to the spring. On the other hand, if we're considering a simple pendulum, then omega, the angular frequency, is equal to the square root of g over L, where g is the gravitational field strength and L is the length of the pendulum. In neither of these cases do we see the amplitude, A. And indeed, regardless of which specific system we're considering, if that system is performing SHM, omega, the angular frequency, won't depend on the amplitude. This therefore means that the time period also doesn't depend on amplitude, meaning that doubling the amplitude has no effect on t. It remains unchanged. Surprised? In my experience, students often are. I've often heard students suggest that the time period should increase, perhaps by a factor of 2. It's useful to examine the roots of this misconception. Even if you answered the question correctly, you'll probably find the following discussion beneficial. To make things concrete, let's consider a horizontal mass spring system where resistive forces are negligible. If the original amplitude is A, then we can sketch the following diagram. If the amplitude doubles, the diagram would look like so. Now, to complete one cycle, the mass now has to travel twice as far. So, surely the time period should increase, perhaps by a factor of 2. This would be correct if the average speed was unchanged, but this is not the case. Recall the velocity time graph for an object performing SHM looks like the following. Notice that the maximum speed is omega a. If the amplitude doubles, then the velocity time graph will look like this. You can see that the maximum speed has doubled to 2 omega a. And indeed, the average speed also doubles. So even though the mass has twice the distance to cover, it's moving twice as quick on average, and so completes a cycle in the same amount of time as the original case or scenario. If you found this video useful, please like it, share it, subscribe to the Forest Learn channel if you haven't already, and leave a comment if you have any questions or suggestions. I'd love to hear from you. Thank you for listening, and I hope to see you soon.